Hey everyone, welcome back. In this video, we will be focusing on topics covered in Lesson 3, the Randomized Complete Block Design. Specifically, we'll be talking about how to create the interaction plot as well as the ANOVA for a RCBD. So let's start by getting to our jump, opening up our file. We can go New Data Table, or we have the stuff right here. So we can go to insecticides, because this will be our first example. Now, just to recall and refresh our memories, our insecticide had 3 treatments and we had 4 plots. And the goal was to see if there was a difference between these 3 insecticides. So to start off, we want to create our interaction plot. And recall that our interaction plot requires us to estimate the cell means. And in order to estimate the cell means, we need the treatment means and the block means. So what we're going to do is we're going to create some new columns. So the first one, new column, we'll call it treatment means. And we're going to go to column property formula. We're going to go to statistical column means. Now, what we're going to do is we're going to go discard that. We're going to go n seeds. I was trying to remember what our variables were called. And then we're going to go by treatment, enter. And so what this is going to do is it's going to create the column means based on the treatment. So press OK. And so let's just look at that. Ooh, apply. Okay. And so what this did was for treatment 1, it calculated the means using these 4 data points. For treatment 2, it calculated the mean using these and calculating the third treatment using these. So let's do this again, but now with the block. So new column, block means, column properties formula, statistical column means. Double click here. You're going to press colon, n seeds, that is seed, that is our response, comma, colon, plot, because we want to be able to make the column means by the variable of plot. Press enter, press OK, press OK again, and now we see that the plots 1 are all the same, plots 2 are all the same. So again, repeat, right click, new column, type in your column name, column property, formula, statistical, column means, then here it's colon, whatever your response is, comma, colon, whatever your variable is. All right. Get rid of that because it's new. Get rid of that. Delete that column. Useless now. Okay, now what we're going to do is we're going to create another column that's going to do our estimated cell means. We're going to go to column property, and this one's going to be a little bit different. And we're going to click the treatment means plus the block means minus statistics column means, and here we're going to put n seeds. So what this column means right here is doing is actually finding the overall mean of every single response. And so this is the formula for our estimated mean. So if you go back and look at our notes, for our interaction plot, we'll see that our estimated means is our treatment plus our block means minus the overall. Press OK, and boom, we get our estimated means. Now we're going to use these estimated means to build our interaction graph. So graph builder. We're going to take our estimated means, put them on the Y. We're going to take our treatment, put it on the X, and now we're going to overlay plot, which is our block, here. Now notice there is some jitter happening, and so you can fix that by going none. Typically jitter is helpful when you have multiple points. Now we want to be able to connect these lines, so we can go add, we'll make these lines here. Then we can add points. Again, there's the dang jitter. And boom, there is your plot from the notes. Press done. You could do a lot more editing with this and whatnot, but just giving you guys the simple overlay. Exit. So now what's really important is how do we do our ANOVA table. So we're going to go to Analyze, and we're going to Fit Model again. Very similar to our complete randomized design. We're then going to take our seeds and put it in our Y. We're then going to take our treatment and our plot and put it in our model effects. Now this is a great way to remember what goes where, is our response is going to come up to our Y. And then our plot and treatment, if we go back to our statistical model shown in lesson 2B, what we're inputting is our treatment effect and our block effect. We don't need to put it in the overall mean because JMP can do that, and we don't have to put in the random error because again, JMP can deal with that and estimate that for us. And so we put in our response, and then we put in our treatment and block effect. Then we're going to press the run button, and we're going to scroll down here. With JMP down here, they're going to go model is 5 degrees of freedom. So what they're doing is putting this chunk together here. And we don't want to look at this. This is bad. If I could draw on this, bad. Don't do this. Where you want to come look is right here. You have your degrees of freedom, you have your sums of squares, you have your F ratio. Notice they didn't give you your mean squared error. To get your mean squared, not error, your mean squared error is right here. MSE is here. But to get your mean squared of your treatment and your block, you're going to right click, columns, mean squared. And that's going to get you your MST and MSB, or block. Your MSE is right here for your error. Okay? Let me repeat that one more time, JMP users. So JMP's going to output this model of 5 degrees. We're not going to look at this line. This F and this P value are wrong. Where you're going to look is down here for your treatment and your block. You have your degrees of freedom, your sums of squares, and your mean squared, and your F ratio. Here's the one you want to look at. Again, you don't want to look at the block's F ratio or probability or P value. For your errors, you can come back up here and look for your MSE, your SSE, and your degrees of freedom. And then you have your total. If you want to do constraints and Tukey's, again, all you have to go to is your treatment, red arrow, constraints, add and subtract as you need to, and then Tukey's is clicking here. Okay? So now what we're going to do is we're going to look at a second example just to show some other aspects. So we had the highway paint data example where we had 4 locations, which is going to be our blocks. We had 4 treatments, and we're applying this. So we're going to open up JMP in a new way than we've seen before. So we're going to go here, and we're going to open it directly from the CSV file. And the reason I want to do this is to show and highlight something that the R users have had to deal with, and then maybe you JMP users haven't yet. So when we load the data, we see that the location was put as continuous, but we know that location in this example would be more nominal because it just would be. And so if we went to Analyze, Fit Model, we put our reflectivity as Y, our paint not as Y, paint as an effect, and our location as effect, and we press run, we're going to scroll down here, And if we looked at our degrees of freedom, we would see that location is 1. And we know this is incorrect because our degrees of freedom for location should be the number of blocks minus 1, which would be 3. So what happened here was that because we didn't turn this variable into a nominal one, it's treating it as continuous, and hence we'll have 1 degree of freedom. So always make sure your columns are matching your intuition of what the variable is. Now, if we go to Analyze, Fit Model, reflectivity is Y, paint as an effect, location as our effect, we run it, and we scroll down here, we can see that our paint and our location degrees of freedom are 3, and that's a great indicator that we're doing our analysis right. So that's also a good reason to understand what your ANOVA table is doing. Again, for your mean squares, you're going to right-click, column, mean square, and you get it.